What's up, code slingers? Hope y'all are having a wonderful day. If not, then go build the next Google. You'll feel better. Today we're going to look at some JavaScript basics, namely primitive data types. Currently, JavaScript has 7 primitive data types that we're going to look at. Today I'm going to use Node as my runtime, but you can use either Deno or even the browser to view the results of what we're going to be looking at today. Since this isn't a tutorial, but only to explain how the data types work and which data types we have, you don't need to follow along, although you can if you want to. So I'm going to be using nodemon because I don't want to keep restarting our file. So now every time I make a change to our JavaScript file, nodemon will track the changes and update automatically. So our first data type is a number. Numbers are very important, and it's no understatement that numbers are the very foundation of computers and all programming languages. Thus, they are very important, and every programming language has a data type of number or several different types that relate to numbers. We can use numbers in any way we want in JavaScript. You can do any kind of mathematical operation with these numbers. So as an example, we can create a function that will calculate the area of a circle given its radius. So we pass the radius as a parameter, and later when we call the function, we can pass a number as its argument to calculate the area of our circle. So we want to log this to our terminal, and then the formula for calculating the area of a circle is pi times radius squared. So in JavaScript, we have a math function that has several mathematical operations, including math constants, one of which is, of course, pi. So we can take pi, times it by our radius, and then we can use a double asterisk to indicate that this is an exponent, so radius squared. Or you can use another math function called math.pow. And then the first argument of our function will be the radius, which is our base. And then the second will be our exponent, which is 2, since we're squaring. And then this will return the radius of our circle. So we're going to give our circle a radius of, let's say, 5, and then we can get our answer. As you can see, we performed a perfectly normal mathematical calculation using our number data type. And as we can see, a circle that has a radius of 5 meters would have an area of 78 square meters. Okay, so that was our very first data type, and probably one of the most used data types in JavaScript. Next, let's look at a second data type, which is a string. A string can be any Unicode character, even emojis. So we can add an emoji over here. As you can see, we can add any kind of character, Unicode character, to our string data type. And like with our number data type, we have several methods we can use on our strings. So to access these methods, we can say dot, and then we have all these methods that we can use on our string. So if we say to uppercase, which will make our entire string uppercase, and log this, you'll see that our entire string is now uppercase. We have several different methods that we can call. We have a split method that will split on any given character that we give it. So if you wanted to split on every character, you pass in an empty string, and it will split on every character, returning an array of our character. Or we can split on a specific character. Let's say we want to split on B. So now it will return an array of characters or strings that are split on the character B. There are many different methods on strings, and my advice to you is to just practice and build projects to learn these methods more. The best way to learn how to use data types and their methods is by doing coding challenges or algorithms on sites like LeetCode or CodeWars. This is how I learned to use data types and their methods in JavaScript in depth. So let's look at a third data type, which is a Boolean. Boolean only have one of two values, either true or false. And these are incredibly useful as they can be used in logical operations to determine what should be done next. So if we log, I'm going to use a ternary operator to check whether something is true or false. So the first argument is a conditional, which will equate to either true or false. And then the second argument of our ternary operator is what we want to happen when something is true. So we'll just give it a string that says true. And the third is what will happen if our condition is false. So we'll just say false. So we'll see if true equates to either true or false. Let's see what happened. As you can see, it's true, so it gives us the string of true. Let's change this to this is true, and this is false. As you can see, this is true. If we change this to false, we will get this is false. This is incredibly useful if you want to run certain parts of your program when a certain condition is met. And in fact, Boolean values can be used with other different primitive data types. So if you have 0, 0 equates to false. So as you can see, 0 becomes false. And any other number besides 0 will be true. And in fact, it can be used with strings as well, where you can say an empty string and it will be false. Whereas anything but an empty string, like adding a space, then it'll equate to true. So the Boolean data type of true and false is incredibly useful for different logical operations. And like I said before, the best way to learn these data types and their methods is by practicing coding challenges and algorithms. The fourth data type we're going to look at is kind of weird. It's undefined. Undefined isn't a data type you're going to be using every day. In fact, it wasn't even meant for programmers to use them explicitly. The data type of undefined is used to track which variables are defined and which are undefined. And in fact, if I don't assign anything to our type for variable, it will result or default to undefined. So if we log 4 to the console, you'll see it's undefined because we didn't assign any value to it. Or we can explicitly use undefined. Undefined, like our string and number, also returns a Boolean value which equates to false. And now let's look at our fifth data type, which is very similar to undefined, which is null. A lot of people confuse undefined and null as they have very similar properties and effects, but in fact they were meant for two completely different reasons. First, let's look at some of the similarities. Both undefined and null return a false value. So if we say undefined and we check whether it's true or false, so if it's true, it'll say this is true. If it's false, we'll say this, we need a string, this is false. And then we can also check our null. So as you can see, both null and undefined equate to false. And in fact, if you say null equals undefined, you'll also get true. So we're checking if null is equal to undefined, and that is true. Obviously, if you use a strict operator to check the type will be false. The reason why the loose comparison is true is because these have very similar properties and outcomes on various different operations. But they can also result in many bugs if you don't understand the difference between the two and know when to use which data type. As an example, let's comment this out, and then let's look at an example. So let's create a function, and we're going to call it test. And in the test, we want it to have a parameter of some value, any value, and we want to log that value. And if we call our test function, but don't give it an argument, we will see it returns undefined because we did not define a value. So if we give it a value, let's say a string, it will return that string for us. Or if we give it a number, it'll return that number since it's the value that we're logging. But if we don't pass in any argument, then it will return undefined. So if we don't want it to return undefined, we can set an optional value. So if we don't put in any value, we can set a default value to say this is the default value, and then we will get that value. So if we again pass in any kind of argument, it'll still return our argument, but if we don't, it'll return our default value. So what if we pass in undefined? Well, then we should also get back undefined, right? But we don't. We get this is the default value because undefined is exactly what it says. It's undefined. It's the same as not adding a value in the first place. So it will default to our default value. Whereas null, which is very similar to undefined but returns an empty value. It's not undefined. So a variable that is set to undefined means the variable is undefined. A variable set to null doesn't mean the variable isn't undefined. It is defined. It is given a type of null, which means it's nothing. It's given a defined value of nothing. So if we log this to the console, we'll see null. So as you can see, there are some differences between undefined and null, and knowing how they will behave in which use case is very important, as you might avoid creating many unnecessary bugs in your program. Let's delete this and let's go to our sixth data type, which is probably the least used of all the different data types and the most weird, and it's our symbol. The symbol returns a unique value that is not equal to any other value. If we log 5 and we check if it's equal to our type 1, which if we see it is, type 1 is a number and it's set to 5, we'll return true, since this is a number and its value is 5. We can do the same for all the other values in our data types as well. But for symbol, let's give our symbol a value of 5, and we create another symbol and we call it test, and we set it equal to a symbol of 5. Since these are both of type symbol and they both have a value of 5, they should return true when you test them against each other, but they don't. And that's the very definition of a symbol, is that each value is unique. As you can see, the test symbol and the type 6 symbol are not the same symbol. They are different, even different in types, since they are unique values. And there are many use cases for why you'd want unique values, such as if you have two programs or apps that need to talk to each other and they both have the same value performing different functions. You don't want those values to be confused in your two different apps, so they will result in an error. So you use a symbol to define those two different values. That will make both of them unique even though they are the same value, and thus they cannot be confused with each other, causing errors. And now let's look at our final data type, which is my favorite, that is big int. Big int is kind of self-explanatory, as it is a big integer, a big number, but it is not the same as a number. So if you pass in 5 here and we log type 1 equals type 7, we have to use a strict equality operator. You will see that they are false. They are not the same type. Even though they have the same value, they are not the same type. The entire reason for why you would need a big int is to display big integers. In programming languages, there is a limit to the largest number every programming language can display. In JavaScript, our biggest number, or our biggest safe number that will be regarded as a type of number, is our max safe integer. And as you can see, here is our integer. That is the largest safe integer in JavaScript that can be considered of type number. As you can see, it's a pretty large number and not many people will be going over this number, but there are use cases such as in science where you would want to go over this number. To show you what would happen if you don't use a big int and you use a really large number, so you take 64 to the power of 64, and as you can see, it returns this really long number in scientific notation. But in JavaScript, as you can see, it throws away 115 digits of our number, since it is over the largest number that JavaScript can display. In science, you wouldn't necessarily want to lose that amount of data. Imagine you get a number from a girl and that number is 10 digits long, and she enters it in your phone, but your phone can only take a maximum number of 5 digits, you will lose the other 5 digits of her phone number and you can't call her back. As you can see, this is a really big problem. So they invented the big int to solve this problem. So if we wrap our expression here, our mathematical expression, in a big int, we'll be able to see the entire number. And notice that there is an n at the end of this number. This is to denote that this is not of type number. This is of type big int. In fact, we can confirm this with unary operator called type of that checks the type of a value. And then we can put over here our type 1, which is a number. And as you can see, the big int is of type big int and our number is of type number. As a result of this, you also cannot use the two numbers interchangeably. You cannot use them together. If you say type 1 plus big int plus our type 7, as you can see, it throws a big error that says cannot mix big int and other types. You have to convert the one to the other. So you either have to convert our number to a big int or our big int to a number, in which case you will have to lose some of the data if you convert it to a number, since it's larger than our number. And those are our 7 primitive data types in JavaScript. We also have a non-primitive data type, which is an object, which we'll cover later, but you can literally write books about the JavaScript object, and people have done that. If you like the video, please like the video. If you like this type of content, please consider subscribing to my channel, as I'll be releasing more videos about stuff like data structures in JavaScript, as well as more videos about JavaScript Basics, and later on more intermediate JavaScript programming. Thanks for watching.